So this is the ninth video on friction. In this video also I'll take up a numerical problem on kinetic friction. Okay. First I'll write down the statement of the problem, then I'll solve it. Question is this. A small body A starts sliding down from the top of a wedge. A wedge whose base length is L. L. The coefficient of friction between incline is mu. Okay. At what value of angle alpha will the time of sliding be least? Time of sliding be least. What is it equal to? Okay. And alpha is the angle which the inclined plane makes with the horizontal, that is alpha. Okay. So now what I'll do, I'll draw the diagram of the situation. See, this is the inclined plane. This makes an angle of alpha with the horizontal. L is the horizontal base length of the incline. The block begins to slide, small block A begins to slide from the top of the incline. And friction coefficient between block and the incline is mu. Now question is, for what value of alpha will the time taken by block A to move from here to here be minimum, and what is that minimum time equal to? Okay, so two things we have been asked. So what will be a general approach? Our approach will be this. We'll first find out the time taken by block A to slide from here to here, and then minimize it with respect to alpha. That's all. Use calculus. Okay, dt by d alpha 0. And from that we'll get the value of alpha, and that value of alpha will substitute in the expression for small t to get that minimum value of time. Okay, fine. And g will appear in the answer. Okay. So this I'll rub it. Okay. L is given. Okay. I'll draw the diagram of the situation here. See, this is the diagram. This is the horizontal base, length is L. This angle is alpha. Block A begins to slide from here, from time 0 starting. Okay. It begins to move down and comes here. First we have to find the expression for time taken by block to slide from here to here. Suppose the block is released from this location at time 0. Okay. At certain instant t, the block A has come here. It's moving down at a speed v. Okay. What I do, see, first what we'll do, we'll find the downward expression of block while it is sliding down the wedge. First of all, we'll find the acceleration. Okay. So we draw the free body of this block with respect to ground frame. Alright. What are the forces acting? mg, n, the inclined surface is rough. Block slides with respect to inclined plane down the incline. So inclined plane exerts a friction force F on the block up the incline. Here sliding is taking place, so F is just equal to mu n, where mu is the coefficient of kinetic friction between the block and the incline. Now we also need to know the value of n. Now block initially starts from rest. Okay, so it's moving down with increasing speed. So its acceleration is directed down the incline, say A. Now to find n, what I do, I apply Newton's second law to block along n with respect to ground frame. Then we get n minus mg cos alpha is equal to ma cos 90 degree. Here what you should write, acceleration of block with respect to ground along this direction, but acceleration of block with respect to ground is a down the incline, so component of a in this direction becomes a cos 90 degree, which is 0. So m into 0 becomes 0. So n becomes mg cos alpha, and I substitute here, so f we get how much? Mu mg cos of alpha, f is obtained. Now I apply Newton's second law to block with respect to ground down the incline. So net force down the incline will be mg sin alpha minus f. Mg sin alpha minus f. This is the net force on the block down the incline. That is equals to mass times acceleration a of the block. F, as we have determined, mu mg cos alpha, is substituted here. Mg sin alpha minus mu mg cos alpha is equal to ma. M goes away. So a is just equal to g sin alpha minus mu g cos alpha. So this is the required acceleration of block down the incline. Now all these quantities are constant. So a is also constant. Okay. Now the block is moving along a straight line with a constant acceleration starting from initial speed. Suppose the block takes t time to move from here to here. Distance which the block moves along the incline is r, say. Initial speed is 0, u. Constant acceleration a down the incline. D barabar ut plus half at square formula we apply. R is equal to 0 into t plus half at square. You should not confuse this t with this t. This is the time instant 0 initial moment, and this t is the time for the block to come from here to here. So t becomes root under 2r by a. Now this is right angle triangle. L is the base, r is the hypotenuse. This is alpha angle. This is right angle. From this right angle triangle, we see that r by l equal to cos alpha. So r is just equal to L by r is equal to cos alpha. L by r is cos alpha. So r is just L by cos alpha. R is just equal to L by cos alpha. All right. And a is this much. We substitute this r and a in this expression. How much do we get? 2 times r is equal to L by cos alpha, and a will be written as g sin alpha minus mu g cos alpha minus mu g cos alpha. Okay, this is the required value of t. Okay, now this are a bit. Okay, fine. Now see, when so t I'll write as root under 2l by this cos alpha, I take inside g common, sin alpha cos alpha minus mu cos square alpha. All right, fine. This I write as 2l by g. This becomes half sin 2 alpha minus mu cos square alpha. Okay, sin 2 alpha is 2 sin alpha cos alpha. 2 cancels out, so this same thing. Okay, now we have to minimize t. Okay, numerator is constant 2l. Okay, so when t is minimum, imply that t square is also what? Minimum, which means 2l by g into half sin 2 alpha minus mu cos square alpha, that is also minimum. This also is what? A minimum amount. Okay. Okay. Now I love this one. Now when this is minimum, now see, only quantity which is variable is alpha. Numerator is constant. So t square is minimum, meaning this quantity is minimum. Meaning this quantity in denominator is maximum, because in numerator of the t square is 2l constant. Only variable quantity is alpha which is appearing in the denominator. This means this means that half sine 2 alpha minus mu cos square alpha is maximum. This means derivative of this quantity with respect to alpha is 0. D by d alpha of half sine 2 alpha minus mu cos square alpha is 0 by the rule of calculus. So this I derivate it, half comes outside, d by d alpha of sine 2 alpha, that becomes 2 cos 2 alpha minus mu d by d alpha of cos square alpha is 0. So this means cos 2 alpha, what is the derivative of cos square alpha with respect to alpha? Minus sine 2 alpha, minus mu times minus sine what? 2 alpha. Okay, that is just equal to how much? 0. I hope it is alright. Here. So this means cos 2 alpha plus mu sine 2 alpha is 0. This means mu sine 2 alpha is equal to minus cos 2 alpha. This means sine 2 alpha by cos 2 alpha is equal to minus 1 by mu. Okay, fine. Is it alright? See, here 2 should also be there. Calculation mistake has been done. Half of sine 2 alpha, so half of, it's alright, fine, okay, it's alright. Okay, fine. So we get, this becomes what? Tan 2 alpha. Becomes minus 1 by mu. Okay, tan 2 alpha is how much? Minus 1 by mu. Just let me just once check the calculation. I have not done any mistake, I suppose. Okay, it's fine. Okay. So tan 2 alpha is minus 1 by mu. Okay, fine. So this is the value of tan alpha. Tan 2 alpha is equal to minus 1 by mu. So 2 alpha is tan inverse minus 1 by mu. Alpha is equal to half tan inverse minus 1 by mu. I hope it is alright. Fine. Is it alright? Clear? Just let me I'll just check the calculation once. Okay. So this becomes half sine 2 alpha. Okay, fine. Now I derivate this with respect to alpha. Half into 2 cos 2 alpha, and this becomes minus sine 2 alpha. Okay, it's fine, alright. So alpha is equal to half tan inverse minus 1 by mu is the answer to first part of the question. Okay. So alpha is half tan inverse minus 1 by mu. That is therefore the first part of the answer of this question. Okay, fine, alright. Now we have also been asked to find out the minimum value of t. So now from this value of alpha should be substituted in this to get the minimum value of t. Alright, fine. Now I'll rub this, okay, fine. I'll rub it, okay. But I'll just once check calculation, okay. Okay, fine, okay. Half 2 cos 2 alpha, alright, fine, okay. So now I rub this, okay. So tan alpha is minus 1 by 2 mu is the required answer, okay. Now we have to find the minimum value of t also. T min we have to find out, okay. In second part of question, we have been asked to find the value of t minimum time. Okay. Now t expression for t is this: root under 12 by g sin for cos alpha is simply half sin 2 alpha minus mu cos square alpha. This becomes 12 by g half sin 2 alpha minus mu by 2 cos square alpha. Okay, this becomes root under 12 by g. Now this 2 goes up. Here we get sin 2 alpha minus mu. 2 cos alpha becomes 1 plus cos 2 alpha. So this becomes root under 4l by g minus mu cos 2 alpha. Okay. Now we have to substitute this from tan 2 alpha. We should get sin 2 alpha and cos 2 alpha. To substitute in this, then we get the required value of t min. Okay. Fine. Alright. Now I rub this. Now see, what is this tan 2 alpha? Tan 2 alpha is just equal to minus 1 by mu. Now this friction coefficient mu is known to be positive quantity. So 1 by mu is also a positive quantity. It is 1 by minus mu is a negative quantity. Tan 2 alpha is also a negative quantity. This means 2 alpha should be more than 90 degree. Because if 2 alpha is less than 90 degree, then tan 2 alpha will not be a negative quantity, it will be a positive quantity. Also, angle which the inclined plane makes with the horizontal, that cannot exceed 90 degree. That should be less than 90 degree, because if this is the horizontal, this is the inclined plane, this makes an angle alpha. Alpha cannot exceed 90 degree, it has to be less than 90 degree. So 2 alpha is less than 90 degree, meaning 2 alpha is less than 180 degree. And 2 alpha is more than 90 degree, so that tan 2 alpha is negative. So 2 alpha is less than 180 degree and more than 90 degree. So what we can do, what we do is this. We set 2 alpha minus 90 degree equal to theta say. So 2 alpha is equal to 90 degree plus theta. Okay, fine, alright. Now I rub this, okay. This last expression I will retain, baki remaining I will rub it, okay. So 2 alpha is 90 degree plus theta. We should get sin 2 alpha and cos 2 alpha. So sin 2 alpha is how much? It's same as sine of 90 degree plus theta. That is equal to cos theta. Alright. And cos 2 alpha is how much? Cos of 90 degree plus theta, which is simply minus sin theta. But still we have to determine cos theta and sin theta. Now 2 alpha is 90 degree plus theta. Substitute in this. So tan of 2 alpha is replaced by 90 degree plus theta is equal to minus 1 by mu. Now tan 90 plus theta will be written as sin 90 plus theta by cos of 90 degree plus theta is equal to minus 1 by mu. Sin 90 plus theta becomes cos theta and cos 90 plus theta becomes minus sin theta. So minus minus goes away. So from this we get that sin theta by cos theta is just equal to mu. That meaning tan theta is mu, because sin by cos is tan by trigonometry. So this means sin theta is mu by root mu square plus 1 and cos theta is equal to 1 by root mu square plus 1. Now what I will do, I substitute this sin theta and cos theta. Sin theta and cos theta I'll substitute. Okay, fine, alright. So, sin 2 alpha is cos theta and cos 2 alpha is minus sin theta. I substitute in this formula. On this side of it, okay. So, T mean will be this. T mean is same as root under 4L by G. Sin 2 alpha is same as cos theta minus mu cos 2 alpha. Cos 2 alpha is same as minus sin theta minus mu cos 2 alpha. Cos 2 alpha becomes minus sin theta. I hope it is alright. This becomes how much? 4L by G. This becomes cos theta minus mu plus mu sin theta. This means 4L by G. Cos theta is how much? 1 by root mu square plus 1 minus mu. And sin theta is this much. So mu sin theta becomes how much? Mu square by root mu square plus 1. Okay, so this becomes 4L by G, this and this we add 1 plus mu square by root 1 plus mu square minus mu, alright. So this becomes how much? 4L by G mu square plus 1 minus mu. Okay, this is the required value of T min, alright. Now I rub that, okay. So this can be rationalized, okay. If you leave it like this also there is no harm. So T min can be written as, I am simplifying it still further, 4L by G, I rationalize it, root under mu square plus 1 minus mu into root under mu square plus 1 plus mu. Okay, so this I can rub it now. D min becomes 4L by G mu square plus 1 plus mu, and denominator becomes a minus b, a plus b, a square minus b square formula. Mu square plus 1 minus mu square goes away. This becomes how much? 4L by G mu square plus 1 plus mu is the answer to second part of the question. Okay. So T min is going to be how much? T min is going to root under 4L by G root mu square plus 1 plus mu. This is the minimum value of T. And tan 2 alpha, this alpha, for this alpha, T will be minimum. So both the answers we have fully obtained. Alright. So this I have fully explained. You go through it properly. In case you have any doubt, you put it in the comment box. I'll clarify it. Okay. In coming videos also I'll take up some more problems on kinetic friction. All types of nice problems I'll take up. Okay. So this I'll close it here. Fine. Alright.